applications within the industrial area. The main way we do this is by introducing odour modelling very early in the planning stage, long before any significant planning decisions are made. We're going to use the Wagga Wagga Special Activation Precinct, or SAP, planning process as an example in this study. One of the key things was developing live modelling. Now, this is where we create the model, run the model, and present the results on the screen in front of everybody in a workshop within about a 5-minute space. You need to create models to do that. It's not a particularly easy thing to do, but once you've done that, it helps a lot. What it allows you to do is rapid testing of different plans for the precinct and different land uses pretty much in real time, or within about 5 minutes, and it allows you to do a lot of work within a few hours, things that might take months to do. The key thing there is getting that information to the planners before major planning decisions are made. This is the study area we looked at in the Wagga Wagga example. It's approximately 8 by 5 kilometres in dimensions. The pink areas are in existing industrial uses. The blue is residential. There's quite a large town, around 50,000 people, just off the screen to the south. And there's the new heavy industrial rail line coming through the middle of this precinct. I won't spend too much time on model setup. A 200-metre grid. The interesting point is that each grid point can act as a receptor or an odour source. That's not normally done. A constant emission rate is used, just unity, 1 unit of emissions at the outset. And we're doing this per the New South Wales EPA odour policy, 99th percentile odour at receptors. It's a 2 odour unit criteria. Here's an example of the model setup. So these grid points can be a source or a receptor or both. The ones on the outside of the area can only be a receptor. That actually changed later, but there. A little bit of time on the scenario testing. We automated scripts that allow the models to run in real time while you're presenting. In less time than this talk, you'd be able to set up and run a model and present it. The odour contours identify areas of high risk for both sources and receptors, and you can do adjustments on the fly as you go. So here's how it looks. So on the left, the big picture is a concept layout for the precinct. The red is the high odour emitting industrial uses, and the green is the medium odour emitting industrial uses. These blue spots were all receptors. There's actually a hotel, resort, vineyard, and things like that in this area, and some houses. And you can see that for this plan, what's being planned on the left, a very large amount of that industrial area would be compromised and cause impacts. And these areas in the bottom right figure are the areas that would be impacted. And you can see that this vineyard and resort sort of area and these houses in the south were problematic, but also houses to the north. Optimizing that could be done in a few minutes in the workshop. In this case, we had a lot of money, so we purchased the properties. These blue receptor properties were acquired. We couldn't acquire things outside of the SAP boundary, so we had to use more traditional planning methods relative to buying properties. But you can see the outcome is much lower risk. If I scroll between those two screens, you can see a greatly reduced risk just by changing that thing. Now, this is one of many scenarios that were tested. The final layout, we did this not just for odour, we also did it for air quality and noise, and we ended up with this yellow buffer line. Every residence inside that yellow buffer line was acquired. The blue one here is a village of around 50 houses on a hill when we couldn't afford that. The more other interesting thing that came out of this was odour allotment. So this is assigning a set emission of odour as a land right or an entitlement per block of land. We're using the term of odour units per hectare. We back calculate to work out what that is, and you can calculate that for the whole area or per parcel of land or individual owner of land. Obviously, the most constraining receptor, the most impacted receptor is determining the allowance. And here's an example of how that looks. I might just zoom in on this one so we can see it a little bit more closely. You can see these are the odour allotments per hectare. They range from approximately 20,000 in the middle through to roughly 2,000 at the edge. And sorry, I can't seem to get out of this somehow. Not sure what I've done. Sorry, everybody. Okay. And yeah, moving on. So the key thing was that these maps went into the planning instruments, and a whole set of rules went in there about how to do it. And essentially, if your development had less odour than allotted to the land, that's all you needed to do to prove acceptability, that you didn't need to do further assessment. If you exceeded that, then you needed to follow the normal route where you would get a consultant to do an assessment. These odour maps are in the master plan, they're in the delivery plan, and we also zoned residential areas outside the precinct and things like that to be able to maintain the buffers. The example here demonstrates how odour modelling at a very early stage can inform better strategic land use planning, how it can be integrated into land use design and policy. It provides clear buffers and criteria for industry up front, so you know how much odour you can make from your lot of land. It can streamline the application process. I should have explained that you can actually trade odour. So if I go back to the earlier slide, you know, a block of land here may not use up all of its odour, and it could trade with a block out here, but there's a 10-to-1 difference in that. So it's a bit like an exchange rate between blocks and things like that. So you can do things like that. It's a template that's been used in other precincts